This video is going to cover some of the vocabulary and language that we're going to use when we're talking about circles. One of the biggest things here is just going to be a matter of when we're all talking to each other about some of the things we're learning about circles, we need to make sure that we understand what we're saying. So today we're going to just cover those vocabulary words, and some of those are going to be the big ones, right? So circle, radius, center, chord, diameter, tangent, things like that. So the first and maybe the most important thing today is this definition at the top, which is that a circle is just a set of all points in a plane a given distance from the center. The reason that's important is because we need to talk about what part of this drawing actually is the circle. So the circle is just this black outside part that I'm tracing right now. The white part inside, that is not the circle. We talk about that as the inside of the circle or the interior of the circle. But the circle itself is that black ring around the outside. None of the other parts of this thing are the circle themselves. From there, we talk about the two kind of things you've probably heard about before with circles. The center, which is just the point at the middle, the one that all the other points are equidistant from. This will usually have some sort of a letter on it, like that, where we might use this to name the circle. So if we call this circle G, we would name it by the center. And then the radius is kind of that thing that defines the circle. It's the segment from any point on the circle to the center, or from the center to any point on the circle. It is the same distance no matter which direction we go. So we go that way, that way, that way, because all the points are the same distance away. We call that distance the radius. So label that on your circle picture. From here, we've got a couple of other ones. A chord is just a line segment that connects any 2 points on the circle. So if I have 2 points, I might call them like A and B. This chord would be called chord AB. It is a segment, so we use the same exact notation as any other segment, the 2 letters of the line at the top. Now, a chord that goes specifically through the middle is called a diameter. Right? So it's still a chord because it connects 2 points on the circle, but it goes through the center, and so we call that a diameter. Right? You'll see diameters in formulas as well, in terms of like the circumference of the circle is pi times the diameter. But the diameter itself is that segment that goes from one point through the middle all the way to the other point. Next up, we've got a tangent line. So a tangent line is a line that touches the circle in exactly 1 point, and we call that point the point of tangency. A tangent line is a line. So if it has 2 points on it, we would name it with 2 points, AB, and since it's a line, we put the arrows on the end of it. So tangent line is a line. We name it just like any other line. Now, a couple of other things that we need to talk about here is just what it means for 2 circles to be congruent. I don't think I gave you a spot for this on your notes, but congruent circles just means that they have the same size radius. So if 2 circles have the same length radius, they are congruent to each other, and we would say circle C is congruent to circle D. I think that's pretty obvious there. Concentric. Concentric just means 2 circles have the same center. So anytime you see that word con, or that prefix con in math especially, that means the same. Centric means center. So 2 circles that have the same center is concentric. Feel free to pause if you want to draw that picture down. An inscribed circle. So inscribed means to draw inside of. So an inscribed circle is a circle that's drawn inside of another figure. Specifically, it has to touch every side to be inscribed. So if that figure has 4 sides, this one's a trapezoid or something, the circle has to touch all 4 sides. That makes it an inscribed circle. The opposite of that is a circumscribed circle. Circumscribed means it's drawn around. In order to be drawn around a figure, it has to touch all the points, all the vertices of that figure. If it skips a vertex, then it's not circumscribed anymore. So there are some properties with circumscribed circles. Now the other thing here is this one is this a hexagon? Yeah. So if we have a circle that is circumscribed around a hexagon, we could also say that this hexagon is inscribed in the circle. So the thing that is on the inside is called the inscribed. The thing that's on the outside is called circumscribed. So the hexagon is inscribed. The circle is circumscribed. Now, this last piece here is arcs. This is where we're actually going to start talking about some numbers today. So an arc is just a piece of a circle between two endpoints. So I might have an endpoint A, I might have an endpoint B, and that piece of the circle right there, remember the circle is just the black line, is called arc AB. We use the same kind of notation we use for lines, so 2 points, the two endpoints, with a little arc symbol over the top. Right? And arcs can go whatever part of the circle we want. It can be a little tiny part, it can be almost the whole thing, but any piece of a circle between two endpoints is an arc. Now, there are three types of arcs. The one that I just drew would be called a minor arc because it is less than half a circle. So arc AB is an example of that. Right? Less than half a circle. A semicircle, you've probably used that word before and never really thought of it as an arc, but a semicircle is exactly half a circle. So if I start there and go all the way around to the exact opposite point, that is a semicircle. Now with this one, if I call this CD, I can't just say arc CD, because if I say C and D are the endpoints, I don't really know which way around the circle. Did I want to go this way like I drew, or did I mean to go that way? So anytime we get halfway around or more, it's important that I add another point in there and use 3 points to label it. And so that tells me that I start at C, I end at D, but I want to pick the direction that goes through E. With a minor arc, it's okay to use 3 letters if you have a middle letter, but we always just assume that if it's 2 letters, it's a minor arc. You take the shortest distance around. The last one here is a major arc, and a major arc is just more than a half a circle. So if I were to start at A, go all the way around to C, that would be a major arc. And just like with the semicircle, we need to use 2 letters. So A and C are my endpoints, and I can use B, D, or E in this case. I'm going to use B. So arc ABC would be a major arc. It's more than half the circle. And then the last thing that we want to talk about here is measurements for arcs. So the measure of an arc is equal to the measure of the central angle that intercepts that arc. So if I were to pick my center, if I say this arc right here, call it AB, the measure of AB, measure of arc AB, is just measured by whatever this angle is. Whatever angle theta is at the middle of the circle, arc AB has the exact same measure. And so if we kind of connect the dots back to this, another way to think about a minor arc would be that it has to be less than 180 degrees. Because a half a circle is 180 degrees. A semicircle, exactly half a circle, has to be exactly 180 degrees. Remember, a full circle is 360, so half a circle is 180. And then a major arc is more than
lunch students are now dismissed for lunch.
180. And less than 360, because we don't want to talk about arcs that are bigger than a full circle quite yet. We definitely can do that in the future, but for now, not quite yet. So measurement of an arc is just equal to the central angle. Biggest things to keep in mind here are you can combine and subtract arcs just like you would with anything else. And if you're doing that, you can use the fact that, circles add up to 360 degrees. So if I were to do something like this, and just say this is 40, and I just ask for all the different pieces of this arc. So I do A, B, CD, something like that. So the measure of AB would just be 40 degrees. If I wanted the measure of AD, well, this line here goes right through the center, so it cuts this in half. That means this whole thing here is 180, which means what's left for this one has to be 140. If I wanted something like the measure of arc, let's go ACD. So that means I start at A, go all the way through C, all the way back around to D. Now I just kind of add up pieces. I know this piece is 40. I know that piece is 180. 40 plus 180 is 220. And if I wanted something like the measure of, let's go BDA. So starting at B, going all the way through D, all the way back to A. Well, that's everything but 40. I know the whole circle is 360, but I don't want that 40 part, so I get 320 degrees. So you can add and subtract pieces of arcs using, half circles are 180, full circles are 360. Any other pieces you're given, just feel free to add and subtract them however you need to get the chunk that you want with those.